In this video, we're going to be solving a polynomial equation. The equation we're going to be working with here is x to the fourth minus 12x is greater than or equal to 8x squared minus x to the third. So the first thing we want to do is get everything on the same side. So I'm going to find my biggest degree. It's a positive. So I want to make sure everything over here makes it to this side. So we're going to subtract an 8x squared and add an x to the third, which is then going to give us an x to the fourth minus, x plus x to the third minus 8x squared minus 12x is greater than or equal to 0. Now from here, we want to try and find our boundaries, which means that we're going to take that greater than or equal to sign and we're going to replace it for the time being with an equal to. So as I look at this here, I'm going to see that they all have an x in common, and I'm going to factor out an x. So I'm going to take an x out, and that's going to leave me with an x to the third plus x squared minus 8x minus 12 equals 0. And then from here, to factor that, you can't really group that. It doesn't factor. So we're going to use the rational roots test to find our possible answers. So I have factors of 1 and 12, and 2 and 6, and 3 and 4 here. And I have factors of 1 and 1 here. So as I list my possible factors, or my possible solutions for these things, I get, so specifically for these things, right, I'm going to x equals a plus or minus. And if you're not really sure how this works, I'm going to take 1 and put it over the 1. Now, because there's 2 of these, I only have to do it 1 time. And then I'm going to have plus or minus 12 over 1. And then plus or minus 2 over 1. And plus or minus. So you kind of get the idea of how that sets up. So when I do all of those and I simplify it down, I'm going to get that I can have x can equal the following choices: plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and plus or minus, oh, I missed the 4, plus or minus 4, plus or minus 6, and plus or minus 12. Now that's a lot of choices to check. So if we go ahead and we plug the equation, right, this equation right here, into our graphing calculator, it will help give us a hint. So I plug my equation in and I graph it, and here I can see that it looks like it's crossing at -2, 0, and 3. So all of those would be great choices to begin with. So let's do the -2. So I'm going to set up my synthetic division, and I only need to set it up with that yellow portion. So 1, 1, -8, and 12. So again, I'm getting that from that first piece. And we decided that we were going to use -2. So let's see, it's going to be 1, -2, -1, +2, 6, -6, +12, 0. So that works. So we just took that from an x to the third to an x squared. Now we also saw that 0 and 3 both worked. Now 0 wasn't necessarily on our list, so we're going to plug in 3. So we're going to step this down one more time so we can make this a little bit easier and plug in a 3. So bring it down 1, 3, 2, +6 gives us a 0, and now we're down to an x. So we're saying that x plus 2 is what was left. Set that equal to 0, and we get x equals -2. So we see that -2 actually had a multiplicity, right? It had a multiplicity. So we can write our factors now for that piece. So let's just go ahead and let's draw a little line over here. So this has now turned into x, and then we have our -2, which happened 2 times, and we had a, so that should be a +2 then, and we had a +3, so x minus 3, and those are going to be our factors for our 0, which means that I have 3 zeros here. I have the 0, x equals 0, x equals -2, and x equals 3. And these are going to be our boundary points. So now we want to pick values that lie on either side of them, but also between them on a number line. So let's draw a little number line here to help us visualize it. Let's scoot this over. So let's say that this is our x-axis, because that's going to help us out later. So we're going to have the boundary points of 0, -2, and 3. So we need some points between them to check. So let's check the number -1, 1, 4, and -3. Those are nice, easy, close numbers. So to check them, we're going to plug them in. Okay? Well, what are we going to plug them into? Well, let's just plug them into something easy. Let's just plug them into our factors. That absolutely, positively will work. So we'll check our -3 first. So everywhere where there's an x, we're going to go ahead and we're going to set in that -3. And when we plug that into the calculator, we see that that's going to give us an 18, which is going to be above 0, or above our x-axis. So now we're going to do the same thing for the -1, 1, and 4, and see what we get. So when I plug in -1 into the x's spots, and then plug that into my calculator, that's going to give me a value of 4, which is also above. When I plug in a +1, I get a value of -18, which is going to be below our x-axis. And when I plug in the number 4, we're going to get a value of 144, which is above our x-axis. Now let's go back really quick and take a look at what exactly the problem was asking us for. It was asking us for where are we greater than or equal to. Greater than or equal to. So greater than or equal to is going to be above. So we want to know, where are we above? So we were above here, and here, and here. And we can include our boundaries, because it said greater than or equal to. Greater than or equal to. So when we write our solution, right, let's give ourselves a little bit more room to write, we can say that we went from -infinity all the way to 0, and 0 was included, and then from 3, which is included, all the way to infinity. That is going to be our solution set. So here we have interval notation, and if I wanted to write that in set builder notation, I'd have x such that x is less than or equal to 0, or x is greater than or equal to 3. So this would be my set builder notation. And so that's how you solve a polynomial inequality.